And we are live. So where did we left off? Okay. Yeah, we are live. We indeed are live. So the X, the Y, the Z work. They work. The X, the Y, and the Z. Yeah, they do work. So the idea is that the rendering right now is messed up like this. Why? I think the problem is that I didn't set up a depth buffer, so we need to set it up. And yeah, that's it. So since it's just boilerplate that I don't remember because I don't have enough mental space for boilerplate, drawing a cube, a very cool resource on Direct 3D11. On Direct 3D11, like programming in C++. Oh no, this is in C. No, it's not in C. No. It's in C++. Yeah. Which basically gives you a very good starting point on things. Anyway, yeah. Frame buffer. No. Depth stencil view. Yeah. So when I create detailable render targets, the swap chain, the create render target view, and then depth buffer desk. You do the thing to get the desk from the frame buffer, and this desk it will be used for creating the depth buffer. How? You just change the format and the bind flags when you're done, and then you create you first create the texture and then you create the depth stencil view, whatever. Now we just whippity woppity. Here is GFX for me. It stands for graphics. Create device. Break on errors. Create swap chain. Create render target view. Fantastic. So get buffer. Create render target view. Okay. Depth buffer desk. This is swap chain back buffer. Get desk. Depth buffer desk. Okay. care about the release because we have smart pointers. Here on the desk we just need to change the format. The XGI format, the bit ZBuffer format that supports 24 bits for depth and 8 bits for stencil. Yeah. Let's go with this. No, wait. Oh my god. Wait. Not S8. Yeah. Okay. The flags and the bind the flags. The bind flags, vertex buffer, index buffer, constant buffer, shader resource, stream output, render target, depth stencil, the bind flags. Here we go. Tac. Depth buffer desk, we get it, the get does not return an error code. Now we create the texture, so auto depth buffer, the 11 create texture, we pass in the device, create texture 2D. That's the desk, obviously. Now we need the device, we need this is stupid, we need the texture 2D, desk, pointer desk, and texture, return texture, 32, check, H result, get texture 2D, the desk, the subras data, and a pointer, so texture dot reviews and get address of So let's add it to the header. Let's use it as a default argument. GFX, so create texture 2D. I have created the depth buffer, so now we can create depth stencil view. I need the device. What else do I need? Depth stencil view and return depth stencil view. It returns on each result, so Win32 check HR and the resource. So the resource would be our resource, the depth stencil view desk, depth stencil view desk, pointer desk. Let's call it const view. I don't care about the const actually. Like const is gay. Most of the time const is very like I don't care. I don't care about it right now. Okay. Resource, desk, and the last step. I don't care about it. So the device, resource, and the desk. What's the problem? Too few arguments. Oh yeah, of course. Yeah, that's it. Yes. So here we need ID3D11 depth stencil view. Buffer depth stencil view. Depth buffer, so here back buffer depth stencil view. D3D11 create depth stencil view passing the device, the resource is the depth buffer get and the desk. Well, I can do this since we don't care about the desk. the doc that says that if the desk is set this parameter to null to validate the other input parameters. No, sorry. Set this parameter to null to create a view that accesses bitmap level 0 of the entire resource. Fantastic. What we want. So we create the back buffer depth stencil view. Yes. All these things, obviously we don't return. When we resize, we may need to release the depth buffer, so the idea is that back buffer depth stencil view release. Okay. Static. Let's define a function for the. Oops. Let's define a function for this. Let's define a function here. Create depth stencil from and target view. Okay. Could I? Should I like put it in the direct D3D11? Yeah, let's put it in the D3D11. Also this thing. Create the extension from render target view. So the idea is that we take a render target view. Okay. Depth stencil, depth buffer desk. Absorption back buffer. We don't really need let's not put it in here then. It's too specific. Let's put it as a private method. Void the the problem is that I got the... Can I do it? Render target view desk though, which is not the same thing. Let's do the old fashioned way. Static. Extensive view. And here we pass the text to the pointer back buffer. Obviously we need the ID 3D11 device, and we are done basically. So we just do this. Oops. Okay. Depth buffer desk. Let's just rename it desk. Nope. Switching back buffer. Just call it back buffer. Here we create a depth buffer, and here we return the created depth stencil view from the depth buffer, and that's it basically. I forgot how to type. Okay, so the idea here is that we release the back buffer render target view, we release the back buffer depth stencil view. The idea here is that once we do it, we first clear the state to release everything. We reset the state for good practice. Then, so nothing is bound. Nothing of our resources is bound. No resources bound. Then we release. Release means release. We resize the buffers, and then we get the back buffer, we create the render target view, and we must create the back buffer depth stencil view. Obviously we need the device, and we need the switching back buffer. Fantastic. I really like it. Now if we run it, obviously nothing will change. Why? We need to bind it in order for it to work, but let's commit. So create the depth buffer based on back buffer. Okay, everything is good actually. Let me check the output. The console output, nothing fancy. sorry, the phone. Okay, back buffer depth stencil view. The 3011 texture to the desk. Yeah. Now, the problem is that we need to bind this. Okay, so we need to clear the depth stencil view, and so we need this, and we need this. So we need to clear so context whatever, clear depth stencil view, obviously alter depth stencil view ngFX dot back buffer depth stencil view depth stencil view. How? Right, it's not that hard. We just do this. Simple get. Yeah, I should rename. So back buffer to do to get. Now we the depth stencil view, and we just want to clear the depth. We set it. Always check the documentation. This value will be client between 0 and 1. Yeah. There we go. Stencil buffer with this value. Now we need to output manager set render targets. When setting the render targets, we not only can pass an array render target views, and also a pointer to our depth stencil view that represents the depth stencil view to bind to the device. So that is that we pass the depth stencil view as it is. Now, I don't remember whether or not we need to configure the depth stencil state. Apparently not. Good luck for us, but as of right now, so here checking the console, everything is fine. So bind use the buffer when rendering. Okay. depth stencil state, it's a good idea to do it explicitly. Why? Because then you know what's happening. If you do it implicitly, so let's use render doc. Let's pull up render doc, load the last settings, launch, capture a frame, capturing a frame, this color path, clear the depth stencil view, we draw index this thing right here, 144. Well, yeah. Now the idea is that pipeline state, vertex shape, rasterizer state, output merger, the blend state, the depth state, depth enable, right, yes, func, less. Now let's go through the documentation to understand what's happening. Stencil task. So the idea is that you want to create rasterizer. Let's put it here. Not D3D11 on pointer, D3D11 depth stencil state, depth stencil state. No. Did I forget? What's your deal? Oh. So depth stencil desk. Let's just call it desk. Let's do this, this, some multi-cursor editing action. Let's go through the documentation because it's very useful. This is stupid. I don't know how to remove it. So depth enable depth testing. Obviously you want to do it. Depth right mask, identify a portion of the depth stencil buffer that can be identified by the depth data. Mask turn off right to depth stencil, turn on right to the depth stencil buffer, and I think I want to write to the depth stencil buffer to record the depth data. Let's oh yeah. Depth func, it's the comparison function, a function that compares depth data against existing depth data. The function options are listed in here. Never, less, equal, greater, not equal, greater than equal, and always. Remarks, a comparison option determines whether how the runtime compares source data against the destination data when storing the new data. So we start from 1. you start from 1 and then very deep, from 1 very deep, sorry, 1, if it's less, so 1 it's very close, okay, I render an object. If it has less depth, if the value is less than 1, I save it, then I render another object. If it's less than my current value, I save it. Oh, I should probably check. Yes. The depth buffer contains depth values between 0 and 1, and it compares its content with the z values of all the objects in the scene. So in the corner, okay. Okay. By default, the depth function less is used. Discards all the fragments that have a depth value higher than or equal to the current depth. Discards all the fragments that have a depth value higher than or equal to the current depth buffer's value. So they okay. Discards all the fragments that have a depth value higher than or equal to the current, so it only passes if the depth is if the fragment's depth is less than the depth in my buffer. So 1 means incredibly close, the closest possible in terms of depth, and smaller values are progressively far away in terms of depth. And the idea is that when you draw something, okay, you've drawn like an object and it has this depth, obviously it's less than 1 because it's not infinitely close to us, it's something between 0 and 1, let's say 0.7, so it's quite close, it's not that far away. If I render another object and this one has a depth value of 0.8, okay, since discards all the fragments that have a depth value higher than or equal discards all the fragments that have a depth value higher than or equal to the current depth buffer's value. So the idea is that I'm a bit confused. I know the reason, because intuitively I would imagine it to be the other way around, but apparently it's not the way it is. It's not the way I think it is. By default, the depth function is used passes if the fragment's depth value is less than the stored depth value. Passes means it writes. So if it is less than, so 0 very close, 1 very far away. Okay, because for whatever reason I started thinking it was the opposite, so 1 very close, 0 to the infinite. No, it's the other way. 0 incredibly close, 1 very far away. Okay, and it is that the depth test passes, and so it writes, it actually writes the fragment and the depth to the fragment to the render target view and its depth to the depth buffer if the fragment's depth value is less than the stored depth value. Less than. It's getting over my head. It's getting over my head. It's getting over my head. Fragments, I want to update the depth buffer. Can set the comparison operator by calling the function accepts several comparing operators. Is used that discards all the fragments that have a depth value higher than or equal to the current depth. Have a depth value higher than or equal to the current depth buffer's value. So the depth value stored in the depth buffer goes from 0 to 1, and it's a measure on how deep the fragment is. 0, it's very close, the closest possible. 1 is the deepest possible. So the idea is that, the fragment passes, we write only if our depth is less than the stored depth value. So if the stored depth is 0.2, so sorry, let's say 0.8, is that how deep I am? 0, 1.8. So 0, 1.8. If I have a depth of like 0.7, it's less than 0.8, so I'm closer, so I write. If I have a depth of 0.9, well, the 0.8 was closer, so I don't write. Okay, fantastic. So the value in the depth buffer goes from 0 to 1, and it's the measure of, and it measures how deep is the fragment. Okay. Clear depth stencil view. Okay, 0 is that rendered fragment is in depth of the near plane, and 1 is that fragment is in depth of the far plane. Okay, and everything between it. Oh, fantastic. So 0 basically the fragment is on the near plane. 1 the fragment is on the far plane. Okay. Oh, fantastic. And that's why you specify the near and far planes in your projection matrix to gain more accuracy of depth buffer. Oh god. Rispetto Ziniere, so interesting. Allow me to these I don't need anymore. The OpenGL projection matrix. Yeah. A lot of math which I don't dislike. Okay. Let's fantastic. Okay, so we actually got something. So to my understanding, if I did this, nothing will get rendered. Oh, yeah, of course. First, yeah. And what if I did this? This would mean something like nothing. Is it because it's too close? Like all the fragments get discarded right away. Fuck, I don't understand why. Okay. Bro. What? Something strange. So basically all my depth values are very close. Yeah. It okay. Okay. It's very close actually. Huh. That is cool. Okay. So we have learned something new today. Or at least I have. which is the cool part. So I should really read that article on the Zinier and the Z4 and the depth buffer resolution, but I'll do it later, maybe not today, but tonight. 10:40 p.m. That's quite late. Fortunately, I have nothing better to do. So the depth enable to true. Depth right mask, yeah, right to all. We want the less for normal behavior. The stencil enable, we don't care. Let's see. The oops. Oh, I just closed the chat window. Docs chat. Fantastic. Obviously, no one is watching, but I still would love to be able to see messages, any sort of message. So there is that depth. Okay, the depth function, stencil enable. We don't care. So we don't care. Oh my, okay. Identify a portion of the depth stencil for reading stencil data. Yeah, portion of depth stencil for writing stencil data. Depth stencil up desk. Identify how to use the results of the depth test and the stencil test for pixels whose surface normal is facing towards the camera, away from. Okay, so these ones don't really care. GFX the price create depth stencil state. We're passing the desk, we're passing the Win32, check HR, we pass the depth stencil state dot releasing at address of terminated invocation. Of course. So the depth stencil state, we have configured depth output manager set depth stencil. So with the output merger, set depth stencil state depth stencil state dot get the stencil ref. What's the stencil ref? Reference value to perform against when doing a depth stencil test. See remarks. There's an interface. Okay. I still don't understand. Oh my god, there is a bug. Fantastic. 0. 0, that is, we do it, nothing should change. Let's call it 5, it's already 5, x, oops, y, z. I should like uncap these values. Target view, target view. Should implement a better camera just to navigate the world, you know, the scene. Later, I first wanted to get models to work. Yeah, it looks honestly, it's not that bad. Let's put it to 0, 0. Yeah, it's cool. So the idea is that we need to set that buffer. We did it. So these we can forget about them, because now we have our GPU mesh thingy. I know it looks bad, all this code like do nothing. Like this obviously is just temporary for getting things to work, like this run thing with a function with a lot of code. Obviously it's not, it doesn't really make sense, but I do it because it's easy to prototype, it's easy to write things when you don't really know what you're doing. If you keep them just in one function, like no problem at all. Obviously it's temporary, but depth buffering and being able to load our mesh, this is eternal, I would say. So let's commit. Create and use depth. Create. So configure, create and use depth stencil state. Voila. Yeah, I think for tonight it's yeah, that's enough. I'm a little bit tired, so okay, bye bye, have a good night.